All right, this is from 6.7, number 51, and it wants us to graph these inequalities, and then we will check to see what their vertices are. Sometimes there's one, sometimes there's more than one. Now remember, when you graph an equation of the line, I think the easiest thing to do is to get the y by itself, and just for a little bit, we're going to pretend this is an equal sign. So if I do that, I'm going to move my x to the other side. So if it's a positive x on this side, when I move it to the other side, it's going to look like this, negative x, and that would be plus 1. Okay, now if this is less than or equal to, okay, if there's this or equal to, when I get ready to graph it, it's going to be a solid line. If it was strictly less than, you know, it would be a dotted line. But let's not worry about that yet. Let's do this. Remember, this right here is your y-intercept. So that's where it hits my y-axis, is right there. So when you graph it online, that's the first point you're going to put on. This is my slope. My slope is a -1. And remember, I can write 1 as a fraction, okay? So this is rise over run. So I always rise, and then since it's negative, I'm going to run to the left one. So you can actually do your next point there on My Math Lab, and then it will automatically put the line in for you. Now mine, I'm doing this on pencil and paper, which is how you would have to do your test eventually on the final. So I am making my slope of 1, so I'm going down 1 over 1. So just a minute, I'm going to have to look through my phone to do this, but I'm going to do this a solid line, okay, because it has the or equal to. If it didn't, it would be a dotted line, but I'm going to go ahead and do a solid line. So let me do this real quick. Okay, and I'm going to extend it out. I'm going to extend it all the way out. Now, like I said, My Math Lab's going to do that for you. Okay, now, that's just for a line, but remember that this was an inequality. So I'm either going to shade above the line or I'm going to shade below the line. So pick any point out there in space. It doesn't matter which point you pick. Just don't pick one on the line. For me, I think the easiest point to pick is 0, 0, and it's below the line. So what I'm going to do is I'm going to plug 0, 0 into this equation, see if it's true or false. Well, look, if I try 0, 0, so I'm going to write this down. I'm going to try 0, 0 into this first equation. Is it true or false? Remember, this is your x, this is your y. Is 0 plus 0 less than 1? And I would say yes, it is. So it's true. Because it's true, that means every point below the line would be true. And so you could have even tried like this point right here, which what is that, 3, -5? Let's say you would have tried that point. Okay, this is your x, this is your y. So if I put 3 plus -5, that's -2. That's definitely less than 1. So I'm just telling you, that's going to be true with anything. So real quick, you're going to, if you're graphing this on MML, you hit like that little paint can and click below here, and it's going to shade it in for you. If you're doing this for pencil and paper, for me on your final, it's going to look just like this. Do it nice and neat. It shouldn't, and so I'm going to shade all of this in right here. Okay, because it's below the line. Now let's pretend you had tried that test point and it didn't work, and then you would just shade on the other side. Okay, so that's that. So we're going to do it kind of halfway neat. Now I'm going to graph this one. Now remember, I like to keep the y on the left. So what I'm going to do, this is a negative y. So I could put it on this side, but I like to keep him over here. So since this x is positive, if I move him to the other side, he's negative. Okay, here's the problem. Yuck, so sloppy looking. I don't want a negative y, I want a positive y. So basically what you're doing is dividing everything by -1. When you do that, you've got to flip your inequality sign. So let me just say, if you change the sign of 1, you change the sign of all. That means you even change this sign. So instead of it being less than or equal to, it's greater than or equal to. Instead of a negative x, it's a positive x. Instead of a positive 2, it's a -2. So this would be my equation right here. Okay, so when I graph that, I'm going to get a different colored pen. Remember, this is my y-intercept. So I'm going to come right down here, and I'm going to graph that at -2. My slope is 1. So that, written as a fraction, is 1 over 1. So that means I'm going to go up 1 over 1. And that's good enough on MML. It'll put the line in there for you. When you're doing it on pencil paper, you're going to have enough to kind of, so you can draw a nice straight line. So I'm going to do that. And again, notice I'm drawing a nice solid line. Boop, boop. I'm going to hurry and just do that. It's solid because there's an or equal to right there. All right, so I know it's on MML. Now I've got to shade. I'm either going to shade below the line or I'm going to shade above the line. So let's look at this. I would pick something, I would probably try 0, 0 again. Okay, it's above the line, so let's try it. If I plug it in, where's my original equation? There it is. Is 0 minus 0, which is 0, is that less than 2? And I'd be like, yeah, it worked. Cool beans, and it was above the line. So that means I would shade everything above the line. Now, I only want where the two intersect. So if I'm above the line, notice I wouldn't shade over here because that's not where they're going to intersect. I'm only going to shade here. And so this is what it's going to look like on the screen. Okay. So this is, you're only shading where they intersect. So my answer, when you do it on MML, you will not see this part shaded in on my math lab. Only the part where they're intersections. So I think you'll have to click on the little paint can to make that disappear. But this is going to be your answer right here, is where the two shaded parts intersect. Now your vertice, this is going on forever and ever. So your vertices are like your endpoints. So I only have this one vertice right here, and it looks like it's kind of in the middle. So I can't just guess my vertice. But what you're going to do is pretend that these are equal signs and solve. Okay, just like you would always solve. And honestly, I would think the elimination method would be the easiest thing. If I add straight down, notice I get 2x. If I add straight down here, my y's disappear, and I get 3. So I get 2x equals 3, which means x equals 3/2. So look here, does that look like it intersects at about 1.5? I'm like 1.5. Yeah, it does. Okay, so that's my x value. Take that, plug it into any equation, and let's see what we get. So I'm just going to use this first one. This says 3/2 plus y, and I'm going to pretend that it's equal to 1. Okay, and you can use either equation because we're looking for that point of intersection. So I'm going to subtract, to get y by itself, I'm going to subtract 3/2 from both sides. Use your calculator when you get to these fractions if you don't like it, but you can see it's -1/2, which is where it should look like it's intersecting. So my vertice is the point 3/2, ugh, my pen is dying, 3/2 and -1/2, because that's what I got up here. Ooh. Okay, so try that and see if it helps.